So let us start with the simulation. Actually, simulation, if you will see, it is a part of operations research or quantitative techniques. Subject is there. It is a part of operations research or quantitative techniques part actually. Quantitative techniques topic is there, which is also you can call it as operations research. It's a separate subject. So simulation actually is normally covered in operations research or quantitative techniques. Okay. So, but here it is given in our syllabus as a part of FM, so we will discuss it. So, what is a simulation? Let us understand first. Simulation means imitation. Simulating means imitating an actual situation. Simulate means you are imitating an actual situation, or you can say a model. You are creating a model of an actual situation for doing some experiment. It is known as a simulation. Okay, simulation is nothing but an imitation of the reality. So before actually doing that situation, when you do a model or do an imitation, it is known as a simulation. Like when astronauts, everybody know, those who do experiments in space, those who go to space for doing experiment, they will create an artificial space-like situation and do rigorous experiments. Okay, so that is known as a simulation. Okay, they will do the space-like situation and do the experiment or practice, you can say, in common language before actually going to the space, how situation will be there, okay, how they have to manage themselves, etc. That artificial environment which is created before the actual, it is known as, that experiment is known as a simulation. Okay, so simulation you can call it is a limitation of the reality. So just you are making a model, like architects also, builders also keep a model, no, of actual project, etc. So that is all simulation. It is an imitation of the actual. Now, simulation is used for solving various problems in day-to-day business life also. That we will discuss how simulation you can use for predicting demand, supply pattern, etc. using the simulation model. So simulation means what to imitate. It is an imitation of the actual environment. Okay, by using simulation, we can solve the day-to-day business problem, that when you should place the order, how you should supply pattern is there, demand pattern of the product, etc. That all we can understand using simulation. Okay, so the simulation which we studied is a Monte Carlo simulation. Okay, so understood what is simulation? Simulation means the imitation of the reality. So before actual environment, you will do an experiment, trial experiment, that is known as a simulation. So where you can apply simulation, say in business. So we are dealing with the financial management. So our simulation will be restricted to the business problems like manpower planning, that you can apply simulation and solve these problems. Transportation problems, investment analysis. Okay, inventory problem, very important. Demand supply pattern analysis, etc. All you can do using simulation. Okay, scheduling aircrafts. So these are all actually in detail studied in operations research subject or quantitative techniques subject. Okay. So how, let us understand how simulation problem will be working. See, actually, to solve a simulation problem, it is a lengthy question. Normally, it should come for 15 marks, simulation problems. Because after solving, you will understand why. Because there are various steps involved in and arriving at a decision. So let us understand with this illustration number on simulation. A retailer deals in perishable commodity. Daily demand and supply are variables. Data for past 500 days show the following demand and supply. Okay. So there is a retailer who is dealing in perishable commodity. Perishable commodity means you know that whose shelf life will be less. You can say up to 1 day. Okay. After that, you will have to throw that goods. You cannot sell that goods. Such type of commodity are known as perishable commodities, whose shelf life will be less. We can say approximately 1 day, like vegetables, etc. Their shelf life is less only 1 or 2 days maximum. After that, you cannot sell that goods. So what this retailer has done, he has taken the data from the past 500 days. He has collected the data of his demand and supply. Okay. And he has found out that these are the his supply pattern and this is a demand pattern. Okay. Means 40 days he receives a 10 kg from the supplier. Like that you can understand. 50 days he will order or he 20 kgs are available with him. Supply means which is available with the retail. Okay, on 150 days he finds out that he is having a stock of 40 kgs with him. Okay, so these are his historical pattern. Now come to the demand side. So he has found out that around 50 days 10 kg demand is there for the product from the customers. Okay, so demand and supply will keep on changing. No? You cannot say that daily demand will be same only from the customer. On 200 days, he found out that 30 kgs has been demanded by the customer. Over the past 500 days, there were 200 days on which his demand was for 30 kgs. Clear? So this is his demand and supply pattern. Now, a retailer buys the commodity for 20 per kg. So a retailer supplier supplies him for 20 per kg and retailer sells the same commodity for 30 per kg. Okay. Any commodity remains at the end of the day has no saleable value. Very important. Since this is a perishable commodity, whatever commodities left with the retailer at the end of the day, it will not have any saleable value. Means it is a loss. So 20 rupees will be the loss if you understand logically, because he is purchasing at 20 and if it is not sold, entire thing will be lost. No? Okay. This is one thing. And moreover, loss unearned profit on any unsatisfied demand is 8 per kg. This is very important. What is the meaning of this unsatisfied demand means? For example, on a particular day, you are having only 10 kgs with you available as a supply. But on that day, if demand was 15 kg from the customer. Okay, so understand 5 kg you are not able to satisfy. Because on a particular day you are having only 10 kg. For example, 40 days are there in which retailer has estimated that he is having only 10 kg. But suppose on that day demand was 20 kg, for example. So 10 kg are unsatisfied. So this will involve a penalty cost of 8 rupees. Okay, so this is the loss on unsatisfied demand is 8 per kg. This also we will have to take into consideration. Okay. Okay, and if you are not able to satisfy, there will be one more risk. A reputation risk will also be there, that you are not able to fulfill the demand, etc. So goodwill, etc. will also be impacted. That is a qualitative part of analysis, but here we are dealing only with the quantitative part. Given the following pair of random numbers, see, you have to simulate 6 days sales, demand, and profit. Okay, this random number is given, see, 6 set are given, see. 1, 2, 3, 4, 5, 6, 2 pairs are given. One is for the sales and one is for the demand. Okay, first one you will take it for sales, second one will be for the demand. So 31 will be for the supply, 18 will be for the demand. So this is a random number. This random number, now you will ask from where these numbers are taken. There is a random number table. Okay. From there you can take the random number, but it is not relevant for you. So it will be given in the question only, random numbers. Okay, there is a random number table. From there you can take the random numbers. See, first random number is for supply and second is for the demand. So that also they have told that 31 is for the supply and 18 is for the demand. Similarly, you should assume for others also. For here example, 81 will be for the supply and 27 will be for the demand purpose. So using this data, we have to simulate the 6 days sales. That in coming 6 days, how will be my the supply and demand pattern? Using this past 500 data, 500 days data, using random numbers, we will predict what will be the coming 6 days demand and supply and profit. Understood everybody? Question? See, all the details are given. Supply details, demand details, random number, etc. are given. First, to start a simulation, you should start with the random number allocation table. First, for starting a problem on simulation, first we will start with the random number allocation table. First, we will start for the supply part. Supply availability, rupees, kgs, number of days it is available, number of days, probability value, then cumulative probability, then random number. So this will be the table for random number allocation. See, availability and number of days it is given in the questions with 10, 20, 30, 40. 10, 20, 30, 40. Number of days 40, 190, 150, and 70. So if we will do the total, it will be 500 days. Okay. Now, what is the probability? What is the probability that on a particular day your availability will be 10 kg? That will be calculated by number of day divided by total 500. Okay. Similarly, probability that the available kg is 20 will be 50 divided by 500. 190 divided by 500. 150 divided by 500. 70 divided by 500. So this is the probability value. Cumulative probability value is simple. First will be same. Second will be first plus second. Similarly, this plus this. So last we should get 1. Okay. This much understood everybody till cumulative probability. Now, to allocate random number, you have to be very careful. Just to listen. Here, if you will see the random number pairs, they are 2 digits number. Okay. 31, 18, 63, 84, 15, 79, 07, 32, 43, 75, 81, 27. They are 2 digits number. So our random number should also be in 2 digits only. It should end in 99. It should not go 100. Okay. If it will become 100, so it should have a 3-digit pair number. But here it is only 2 digits. All random number given here are 2-digit number. Okay. So we should take care that at last it should come 99. Okay. It should not go 100 because 100 is a 3-digit number. But we are having only 2-digit random number. So what we will do, we will start from 0, 0. So we will start from 0, 0 to 0, 7. 08 to 017. Sorry, 08 to 017. Okay. Then 018 to 050. Sorry, 18 to 55. 56 to 85. 86 to 99. Okay, listen once again. Probability value, how we have calculated. Number 40 divided by 500. So each day's value you will take and divide it by the total. Okay, 40 divided by 500, 50 divided by 500, 190 divided by 500, 150 divided by 500, 70 divided by 500. Understood? Each day's particular value divided by the total. So you will get the probability values. Clear? Cumulative probability I will find. First will be 0.08, same. Second, how we have to do? 0.08 plus 1. You will get 0.18. Okay. Then 0.38 divided by 0.18. You will get 0.56. Then 0.3 plus 0.56. You will get 0.86. Then 0.4 divided by 0.86. You will get 1. Clear? This much everybody understood? Okay, so understood how to calculate probability. Individual value divided by the total. Individual value, that is 40 divided by 500. Okay, now understand. Since here random numbers are two-digit number, we have stopped in 99. So you should not go 100. If you will start from 1, what will happen? It will start from 100. It will stop at 100. That is a different issue. But now understand how we have allocated. That is important. We will start from 0, 0 and stop at 0, 7. There is a trick you can say. See here, cumulative probability is 0, 8. So you should stop one less. 0, 0 to 0, 7. 8. 8 means you will stop at 7. Then next you will start from 0, 8. And you will see here it is 18. So we will give 17. Then next pair we will start from 18 and it is 56 here. So we'll stop at 55. Then we will begin at 56 for next pair and see here cumulative probability is 86. No? So we'll stop at 85. Then we will begin at 86 for next pair. 1 means 100. So we'll stop one less, that is 99. Understood how to allocate this random numbers? One less you should stop from the cumulative probability values. Okay. So it is 0, 8 means you will stop at 0, 7. Then start from next 0, 8. 18 means you stop at 17. Similarly, 55. 86 means 85 you will stop. And 1 means 100. You will stop at 19. Clear? Okay. If you want to understand the logic, that also you can understand. If you will count from 0 to 7, you will get 8. You should get 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. No. If you will count from 0, 8 to 17, you should get 10. If you will count from 18 to 55, you should get 38. Count and see from 18 to 55. 18, 19, 20, like that. If you will go till 55, you will get 38. If you will count from 56 to 85, you should get 30. And if you will count from 86 to 99, you should get 14. See, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. 14 you are getting. So this is the logic for allocation, but you don't go that much. Just to see that one less you're stopping. So if cumulative probability is 8, you stop at 7, but begin from 0, 0. If cumulative probability is 18, you stop at 17. If it is 56, stop at 55. If it is 86, you stop at 85. And 1 means 100, you stop one less, that is 99. Clear everybody this much?